Strings are essential and versatile in Python, enriched with a suite of built-in methods. Let's jump into our first set of techniques and understand their input and outputs. First up, the capitalize method. Given the input, 42 hello, the output remains 42 hello, since only the initial letter of a word is capitalized, and numbers aren't affected. With casefold, the string, hello I, transforms to the lowercase output, hello I. The center method can be used to center align a string. Inputting, hi, with a width of 3 and a filler character asterisk, gives us the output, asterisk hi. Ljust and rjust are perfect for left and right justifications. Using hi, with a width of 3 and asterisk as the filler, we get hi asterisk and asterisk hi, respectively. Swap case inverts the case of each character. For our example, hello world changes to hello world. The title method, given hello world, produces the output hello world, capitalizing the first letter of each word. For a simple transformation to uppercase or lowercase, the upper and lower methods are ideal. The string hello world becomes hello world and hello world, respectively. Now, to trim characters, the strip method is handy. From the string xyz hello xyz, when we strip away the characters xyz, we get hello. If you wish to trim characters only from the left or right, use lstrip or rstrip. From xyz hello xyz, stripping xyz on the left gives hello xyz, while doing it on the right yields xyz hello. In this segment, we will explore Python string methods that help us gather information about strings and perform checks on their content. Starting with isolnum. This method checks if a string contains only alphanumeric characters. Given the string, hello, it returns false due to the exclamation mark. With isalpha, we verify if all characters in the string are alphabetic. For the string, hello, it too returns false. The asashii method checks for ASCII characters in a string. For instance, the string ello gives us a result of false because of the special character a. Using is decimal, we can determine if all characters are decimals. The superscript 3 cubed interestingly returns false. But if you check the same character with isdigit, it returns true. Next up, isIdentifier. This checks if a string can be a valid Python identifier. For 3var_name, it's false as identifiers shouldn't start with numbers. Islower and isupper test if a string is in lowercase or uppercase respectively. Hello returns true for islower and hello for isupper. To see if characters are numeric, isnumeric is handy. The superscript 3 cubed will return true here. If you wish to determine if all characters in a string are printable, isprintable does the job. For the string n hello, it returns false because of the new line character. The isSpace method checks for whitespace characters. For the string tn, it returns true. With isTitle, you can check if a string follows title case. Hello, world returns false because of the comma followed by a space and an uppercase letter. Lastly, starts with and ends with methods verify if a string begins or ends with certain characters or tuple of characters. For instance, hello returns true for starts with h, a, e, and filename.txt is true for ends with .jpg, .txt. Part 3. String search and replacement. Moving forward, let's now explore how we can search for specific segments within strings and even replace them using Python's versatile string methods. We kick things off with the find method. It searches the string for a specified value and returns the first position of its occurrence. If the value isn't found, it returns -1. For instance, the string hello hello returns 7 when looking for the character L between indices 5 and 8. Now, our find works similarly but returns the last position where the value was found. Using the same string and criteria, it still returns 7. Next, we have index. This is similar to find, but instead of returning -1 when the value isn't found, it raises an error. In our example, the string hello world provides the result 8 when searching for the character L between indices 4 and 9. On the flip side, rindex gives us the last position of the value. For the string hello hello, looking for L between indices 0 and 6, the result is 3. Let's say you need to replace parts of a string. That's where replace comes in handy. For the string AABBCC, replacing the first occurrence of A with Z gives us the output ZABCC. If you want to divide a string based on a specific delimiter, use the partition method. For the string hello equals world, partitioning around the equal sign gives us a tuple hello equals world. Similarly, our partition does the same but starts the search from the end. With hello equals world equals Python, we get hello equals world equals Python. Finally, the count method comes in handy to determine how many times a specific value appears in a string. For the string AABBCC, counting the occurrences of A between indices 1 and 4, we get a result of 1. We'll commence with the encode method. If you've ever needed to convert a string into bytes, this is your tool. Take the string hello. Encoding it with the ASCII format results in a bytes object, displayed as bhello. When it comes to string formatting, Python offers the format method. It places specified values in a string. An illustration of this is formatting today's date. Today is %b%d, %y, becomes today is August 11th, 2023, given today's date. Similarly, format_map is a neat method for integrating dictionary values into a string. Name, age, formatted with a dictionary containing John and 30 outputs, John chapter 30. Tabs can sometimes be pesky, and the expand tabs method is here to assist. By default, a tab is equivalent to 8 spaces. Using expand tabs, you can modify this. Hi, T there, with a tab size of 2 changes to hi there. Now, suppose you have a string and wish to ensure it has a certain length by padding zeros. zfill is at your service. The string -42, when padded to a length of 5, becomes 0042. Last but certainly not least, maketrans is a gem. It creates a translation table. For instance, creating a table that translates A to 1, E to 2, and I to 3, while removing O and U, opens up fascinating text transformation opportunities. We now move to our final segment, string splitting and joining. These methods form the heart of many data parsing tasks. Starting off with the join method. It's akin to a string's magical ability to unify. Given a list of words, like hello, world, we can seamlessly join them into a single string, resulting in hello world. In contrast, the split method does just the opposite. If you've got a single string, hello, world, Python, and you want to separate each word, this method breaks them apart using a separator, such as a comma, turning it into a list, hello, world, Python. Taking a slight detour, rsplit works just like split, but starts its work from the end of the string. It's particularly handy when you only wish to split the string at the last occurrence of a separator. Lastly, split lines is your go-to for line breaks. It takes a string and divides it wherever a line break occurs. So, hello, and world is split into two separate lines, hello and world. By mastering these methods, you'll equip yourself with powerful tools to manipulate and analyze textual data.